everyone, welcome to Under the Microphone, the podcast where we talk about the fascinating world of science and the people who make it happen. Today's guest is Bianke Loedolff. Bianke is a researcher and innovator working in the space of functional foods, alternative crops, and translating scientific research into real-world sustainable solutions. Her work on microgreens and fruit innovation really inspires me due to her potential impact on nutrition and food security. Welcome, Bianke. Thank you very much for joining us today. And for those who might not know you yet, where did your story begin and how did you end up working in food innovation?
Let me put it this way. My story probably started with my mom saying I am an extremely weird baby because I only wanted to eat vegetable purity, let alone chocolate, no meat, nothing. So I actually believe my story started there with vegetables, plants. And as I got older, I used to hang around in quite a few greenhouses and also places where people would do in vitro culture. So I had some taste of a laboratory biotechnology. And as I went through high school, my only thing I knew in matric, this is what I want to do. I want to become a biotechnologist, and I was going to pursue that with every might. Wanting to do science to show people how we can use plants, everyday plants, for our health and our medicine and nutrition. So gearing myself up to getting a PhD was really to translate all of that knowledge back into society.
So when did you start working at the university?
Maybe I must clarify that a whole lot. So I don't necessarily work for the university, but I am appointed an extraordinary lecturer. So I do have opportunities at the university where I can pursue my research, my mind, unpack the science that I want to translate into the world and supervise projects. So that's how I gear myself within a university structure as an entrepreneur.
So we mentioned that you do your innovation in or your research in food science.
It's not necessarily food science. So I integrate many different disciplines. So as a biotechnologist, I take the concept of biotechnology out of the world of genetic manipulation. So for me, I also need people to understand that biotechnology is not just a pursuit of generating genetically modified organisms. I try and integrate many disciplines and not make science just one box, but try and link many boxes together. So I integrate food science, and I would integrate many other foundational cornerstones of science into what I do. For me, it's how we apply the knowledge and not necessarily excelling in one particular discipline.
What are you currently working on?
So my current work largely focuses on nutrition and on trying to innovate with different ways of either designing our foods, maybe think about foods of the future, or designing fun ways of just using what we are so used to everyday eating in different ways. That is one part of what my biggest passion is currently, and always has been a driving part for me is human health and nutrition. And how do we not just analyze our plants for what they have, but how do we actually use them for the better, for our health and nutrition going forward?
What made you decide I want to help create sustainable food sources or nutritional food sources and make that a career?
The Sustainable Development Goals of the United Nations that came out. When I started looking at that, I was mentoring on a big global platform, Future 17, where many businesses from across the world participated. And you also start seeing there's not a lot of understanding around sustainable agriculture. Again, people pursue science and they pursue degrees, and there's no real translation as to why you are actually doing something, the way you are doing it. My big thing is starting to understand, or it was starting to understand the world, which is why I say I'm at this intersection of higher education and what is actually happening in terms of industry and what the world really needs, not wants. With these two very clear perspectives at hand, that's how I go about making decisions. Now, if you think about sustainable agriculture, sustainable food production, these are buzz terms that people also throw around very, very lightly. The practices that you pursue when you're going to something sustainable doesn't it doesn't come from helping to solve a problem in your world. It actually arises from a need within your immediate community, society, or country, or nation. And that is where I seat myself first, seat myself here. And what I see is so many missed opportunities. And that is what I want to show people. Missed opportunities of having a 5 by 5 square meter garden. You cannot imagine how many good food you can produce there. And that is agricultural biotechnology. So again, I must just say I mix quite a lot of disciplines as a biotechnologist. And the agricultural part of it and sustainable farming practices is also one of them. Sustainable food production comes from that, which is why everyone is looking at alternate proteins and quickly finding out that cellular animal agriculture is not so cheap to pursue. It's not so nutritious to pursue. Hence the alternate plant protein market. Now, if you go into alternate plant proteins and legumes, there's a lot you can do in terms of growing it yourself as well.
Do you use it as an alternative to food?
Absolutely.
Up to me.
So this was a fun part of our very first try out in the falafel project. Part of the passion for that MEC learner was cooking. We put up a challenge to bring out a little sideline cookbook, a recipe book, for what other purposes you can use this pigeon pea for. And that was smashing. So it's not just about telling people, you're right, it's not just about telling people there are legumes, grow them and eat them. How to cook with them is another thing. That's maybe not so biotech, but that is the end product after we are finished with our science, is to show people how do you use all of this that you can grow, and then to explain all the nutritional sides and facts of it.
You sent me an article, about your microgreens. Can you tell me a bit about what that is and how your work in microgreens started?
That was one of my first pursuits at the institute while I was doing my postdoctoral. So at the then director, Professor Jens Kostman, he passed a few years ago, gave me an opportunity to come forward with my mind's ideas and wanting to bring that into biotechnology. I try to find something that we can eat, easy to grow, consume, that is absolutely densely packed with nutrition. As we look at the staple crops and things of food today, it takes you a long time to harvest, seasons to harvest. And I came across microgreens, which is a culinary concept, really. People love garnishing in a restaurant with these tiny little microgreens, which are basically small, immature plants. I did publish some articles in the microgreen science area. And it pretty soon became clear that, publishing articles is also very descriptive. And it sits in the article and you never do anything with all that knowledge. And for me, I'm like, no ways, we can't do science this way. We're generating all this knowledge. How are we going to show people how to use this? What are we going to do with the knowledge? Apply it. So not only applying, but then translating now for projects, any kind of microgreen. It's not about eating the microgreen. It's about actually using the microgreen in something else.
What are you growing at the moment?
We just finished a project with carrot microgreens.
Is it like tiny carrots?
Well, it's actually not tiny carrots. It's carrot tops. Okay. So you don't really see the carrot in the microgreen, but you'll taste it in the microgreen. And that is the essence of the microgreens. The essence of what I try to instill in terms of translational science is gearing a learner's mindset towards how do you now further take this microgreen and do something, design a product. Let's design a product and let's have consumers test that product of ours and see whether they like it or not.
Just in terms of the microgreens, that product that you want to sell, what would that be? Would that be something that someone puts in a salad, or how do you foresee that being used as a product?
Probably translating it even further than just putting it in a salad. So let's consider growing a microgreen, and you got your microgreen, and you cannot keep it. You have to eat it very quickly because you can't preserve the actual fresh product as it sits. So the idea is always to preserve the nutritional punch from the microgreen, which is at that stage of microgreen development is super, super high, super dense. And the essence there is to not directly consume it, but to convert it into something that is a product. Those are now the latest one with the carrot microgreens, where we did all of the legwork. We know what health properties are sitting in the microgreen. We used what we would say is green extraction method. So extraction method using a microwave. It's almost like making tea. It's very simple. Literally 30 seconds, 1 minute, extract your compounds or your metabolites from the microgreens. And we incorporated that into a sphere. So this is sodium alginate, which is something from seaweed that polymerizes during a certain method. And it then captures the microgreen nutrition within the sphere.
Would that mean, like, if you're doing carrots, does that mean the spheres are orange?
Very good question. No, they're not, because the microgreens are not orange. In fact, it's quite clear the solution that comes out.
So it just looks like jelly balls.
Yes. The anticipation for commercialization or a product establishment is now not just to sell the spheres, but how do you convince someone to actually now want to take those spheres, never mind the health benefits. So we suspended these spheres in a bottle of water, hence the name. So hydration, nutrition on the go. And you get everything all in one. And that is the aim of what we really try and do, is get consumers something that they want to partake in, and that's actually also quite health beneficial.
So is the product on the market yet, or is it going on the market?
Yeah, so Megan Oosthuizen was the learner who did the MSc. So she will graduate now with all of the legwork running that. And of course, moving forward, indeed we want to bring that as a product on the market. I might venture out there and say we will happily pitch and happily partner with people to bring that on board as well. I have to maybe disclaim as well, as an entrepreneur in the education system, my ultimate goal is not to necessarily open up many businesses and to go and bring out all kinds of products. It's really to show our next phase of scientists, people who are interested in studying science. How can you actually use your science knowledge in the simplest of ways to make something for the community, make something for society that's beneficial?
That is actually something that's very critical in research. A lot of scientists, they actually just do the work or do the research and they publish, but they never do anything with their research or take it further to a commercial product. So how do you make that jump, or how do you influence your students to make that jump from not just doing research, but actually doing something with it and taking that next step?
Yeah, sure. That is not necessarily easy to just talk about it. So my principle is show. Let us walk a journey together, and as far as I can, with one foot in education and one foot in industry, like what is necessary to bridge your scientific learning with what is required out in the world. And the essence is to immerse yourself, and that is where our training is going to. I lead an innovation hub here, and this is where a lot of chatter and design is happening. So together with the current director of the institute, we are doing this translational science going forward, bridging it and demonstrating with the learners in an immersed fashion. So for me, I don't talk. I'm not going to say, go and commercialize and this is what you must do, because people actually don't understand how difficult it is to go from, hey, listen, I've got a product, to, hey, listen, my product is on the shelves. The time in between all of that and what you actually need to understand about the ethical nature of what you need to do, that is where the education now for me is coming in super strong. Our first such project was done on a concept of falafels, which is something that many people maybe now know. But we tried just before the Innovation Hub was fully established. We tried our hand at reinventing or rethinking something that everyone might be aware of. And we created falafels.
Is that now an alternative meat source?
This is now alternative protein. Yeah, so this is going into the legumes. But now just talking from the commercialization aspect, where we couldn't prepare ourselves for what was to come. And one of the biggest learning lessons there in terms of how you think about training for commercialization is what do you need to be ready when that phone call comes?
You mentioned legumes. Did you just grow legumes? How did that develop?
Oh, yeah, so legumes started out also with my partner. Parents got what we call a pigeon pea legume tree. Grew up eating these kind of legumes and realized that there's really not a lot of research going on this in South Africa at that time. And we might be missing the boat with alternate proteins here. So everyone's focused on alternate animal protein as per se, completely missing that plant alternate proteins is actually going to probably skyrocket, which is what's happening currently. And we decided, okay, we're going to go into the venture of starting to investigate legumes. For now, it's an academic venture, and then there's the entrepreneurial venture. So we started with pigeon pea. There's a couple other legumes in play as well, but that was the initial part of it. So what is the nutritional value of these legumes? What is it similar to? Understanding that chickpeas are also legumes, but chickpeas is like the legume that people know across the world. All the other legumes are just, if not better than chickpea, and nobody is using it. Nobody knows about it. So the essence there was, can we actually just start something to show people there are legumes out there, show people the incredible nutritional profile of these legumes? And we sat and we said, how are we going to do this? Because you can't now go and do an analytical on the metabolites and tell people, hey, look at that protein content of the legume. No one's going to be interested in that. Give me a product that I can eat, and maybe then I'll listen to what the nutritional content is. So that is where we started completely shifting how we think about projects at the university, the higher education.
I know you were working on a meat, alternative meat that was nodules growing on plants.
Yes, when we look at meat or animal alternatives, I have dabbled there as well. I've grown animal. I almost want to say, a white biltong.
Interesting.
Many people don't know that your cellular, your alternate animal products, the meat that comes out of a laboratory does not look like meat at all. It's white. There's no blood. There's no nutrition in it. So, okay, protein. Let me not say no, nothing. But I think about nutrition a very different way. I think about what is beyond just our proteins and our vitamins. Nonetheless, the white is something that nobody wants in terms of consumerism. Right? So people are dyeing meat alternatives with, for example, beetroot, and it's acceptable. Nothing wrong with that. But we do also have, this is where my fascination with biotechnology will come in. We've got alternative routes to produce something from a plant that could be used in the future to color alternate meat or protein products. That can be for animal or for plant proteins. Now, still on the same leg of legumes, these legumes have a very interesting feature. Only legumes have it, where they make symbiotic nodules on their roots. Now, within these nodules, these are like little houses for very particular group of microorganisms that assist the plant with its nitrogen uptake and processing. Now, as a scientist, we have learned, now, take that legume, take the nodule, and there's a particular gene in that association. So you have to have the association with the bacteria and the plant. What we then do is we'll take a specific gene, a piece of the DNA out from this nodule association. And we would make recombinant protein in the laboratory. That recombinant protein is something that gives a red color. So it's a heme binding factor. You can get sort of your iron as a biofortification
This compound
strategy.
that's found
as
in
well.
blood, right? Yeah.
Yes. So the function is the same for that particular gene from the legumes, the nodules.
How does that compare to meat then in terms of flavor? Does it taste like meat?
Well, that that is probably going to be super debatable depending who tastes it. Different leg hemoglobin. So we call the gene that you take out as a leg hemoglobin, akin to a heme. They will all have different color profiles. So in the range of brown to red to light pink. And they will also all have different sensory profiles. So that is my next mission. Again, for any partners wanting to come along. How are we going to exploit, these leg hemoglobins? Because we can mass take all of them out and get a range of colors, get a range of maybe nutritional profiles, and a range of tastes.
This podcast is proudly sponsored by Michem Dynamics, a consulting, auditing, and training partner working alongside laboratories, food safety, and quality teams providing services across the world. Since 2014, Michem Dynamics has helped companies go beyond just technical compliance, helping them build systems, leadership, and culture practices that put people at the heart of quality. They believe that reliable results, products, and services comes from humans that feel safe and supported and not pressured. And that when organizations feel safe, respected, and purpose-driven, excellence follows naturally. Michem Dynamics stands for Safe and Healing Organizations, and that strong organizations are built on trust, care, and conscious leadership. So how do you get the projects? Do the students come to you, this is something I want to work on, or do you do the research, and then how do you get these students to collaborate with you on this?
Me and Sean Peters, the current director at the Institute, we have been working in partnership for a really long time. So when it comes to the ideation, it works. And we try and think of different aspects in the world that we can bring our science into. So brainstorming, listen, I would actually say that to anyone. If you can find someone who can gel with you in terms of your thinking and your ideation, go, stick to that, because it is incredible when minds come together, how to ideate and bring projects about. Then, it's not necessarily that a learner will come to us with their idea, but we wouldn't say no to that. They will generally come and speak, and one would hear the interests of a learner. And it is very, very often that sometimes through a conversation, the project will come and we will start defining in the background, and we'll contact the learner again and say, hey, listen, we got a project. And that is how you drive the passion, because I listen, I hear what you guys are interested in. So let's try and train you on something that you already find interesting. And How maybe you can step away with the product. So that is something we try and do.
Okay, so it's part of a class, or is it part of biotechnology? Are these all biotechnology students, or are they from different faculties?
We would never put a box only on a biotechnology student. Of course, as it goes in an academic setting, yes, you do undergrad and you kind of shove that way, do your biotech. You did that in undergrad as well. But here, for me, an undergrad in science, you learn very particular things. And if you only walk away with what the scientific method is, that's good. And you can literally go and this is maybe my opinion here, but if you use that knowledge the right way, you don't need to do biotechnology. You can do many other disciplines. And so vice versa for me. If you with, for example, a BSc psychology, it's a science, BSc science degree, you'd be amazed what you can do with your psychology and biotechnology going further in a biotech degree. So I don't box. That it's only biotech students.
What made you take that leap from okay, I want to help these students, make something out of their idea, to innovate and do something with their research instead of just publishing and letting it sit in some library somewhere?
The essence that's driving me and still driving me today, when there's a constant talk about there's no jobs, there's no I'm graduating and there's nothing for me, to go and do. And instead of getting angry and frustrated, big thing for me is what else can you do with science? Because science, you came to the point of pursuing science because hopefully you're passionate about it. But you don't need to end up in a scientific arena, right? The biggest thing for me is to show the learners what else you can do if you think with your science degree. And for me, this is, can you do science communication? Because there's a one-way street when we come and do science. And that one-way street is, I need to end up in academia. I need to become a professor, and then my science reputation is going to be good. And I think the pursuit of science has been skewed over time as to where a skill like that takes you. And in terms of science communication, in terms of analytical thinking, do you think you can't head up a huge bank with your analytical mind as a scientist? I challenge our learners that way. Yes, you find science interesting. There are so many things that you can pursue with your knowledge. Don't think about science as a career. Think about it as a pursuit. And how are you going to make something from it?
And another thing that's in the way for students is it's not only getting to that point of innovating, but also getting to the point of bringing something to the market. Are people going to feed into your idea? Are people going to buy it? Is it something that someone would want to invest in? So how do you inspire students to take that leap, to go past the doubt and the insecurity, and just actually take the leap and take a chance?
Listen, you take that insecurity with you. Take it. There's nothing wrong with being scared, being insecure, and being completely crapping yourself. Just move forward. Best thing is there are actually people who want you to do it. Find the people. Then go find people to talk to show you what to do. Now, that is the other thing. You were just asking me, what must you show people? How must you do this? Okay, this is where I feel very strongly about bringing business and entrepreneurship thinking and aspects into the science world. We look at not only science, we look at what is a target market. Like if you design something, why are you designing it? Because you have to forecast whether someone might even enjoy your product, whether it's only you that thinks this is a brilliant idea, which is mostly the case. As scientists, 95% of our ideas are really not super great, but we would imagine it is. So that's the route that that I'm investing in, is showing what other pieces of information you need that you might not have known if you had only pursued science. So we marry science and business, and you get to do a business plan. You get to understand how to set up a business. You get to understand how the different aspects of it work. And with all that, the hope is go out there and find something that not you like, but that is going to assist. Use your knowledge to assist. Find something fun to do.
So how did they get to working with you? What uh, subjects do they need to have in order to work with you on a project?
Oh, usually this would be your typical undergrad stream. It would be biotechnology is obviously the biggest thing, and not everywhere you've got subjects of biotechnology, but genetics, microbiology, biochemistry, food science, even engineering. So those are all principled areas that I work with, or disciplines that I work within. So anyone from any of those fields.
Okay, so they can approach you and say, listen, I want to work with you. I want to learn how to bring product to the market.
For sure. Even just have a chat to see where we head off with that,
Yeah, you mentioned in one of your articles that there's so much better food sources than flour and rice, for example. But again, a lot of people and their staple food is rice and flour and bread. So how do you change their mindset to go from, eating something that they used to eating on a regular day to moving to a more sustainable food stores like legumes, and still, having something to have with their meat or their veggies?
Certainly a difficult point. And I don't believe education alone is going to assist anything down that arena. Everyone always stops. Yes, we must educate everyone about the legumes and how healthy it is systematically. This is just, you just have to be diligent, patient, and communicate with society out there. There's a lot of products currently on shelves in the health shops that's legume forward, that's alternate protein forward. The problem with, now I'm going to do this, sustainable food production is that it always ends up on the most pricey of shelves. And if I can change anything, that's where I'd like to start, is to help people understand that this is actually not even the reality of producing legumes for something to be that expensive.
That I've also noticed. Yeah, if you want to buy alternative or different types of flour, it's always in the most expensive packaging on the more special shops or the health shops or vitamin shops. It's never just on at the grocery store. Is it because it's specialized, or is it because it's specially produced? Do you foresee that changing if it was mass produced?
Yeah, I do foresee that changing. Maybe not super soon, but there's already a spooling that is happening. When we understand our farming practices or agricultural practices, and perhaps how to produce maybe alongside our staple crops, we would start generating and start inbuilding a natural affinity for other crops. So the hope is that we're going to end up going that route. So listen, agriculture and the 5 staple crops that we have out in the world has been coming from the 1960s. And it has been a perfected agriculture art form, which is why those staple crops are there. Now, the biggest problem with our staple crops in the world globally is climate change. Oh, and everybody loves to hear about climate change. I don't like blaming anything on climate change, but listen, we are here and that is a reality. And the agriculture, as we see it today, is suffering already. And that is perhaps the first starter for us to then explain this. And there's actually some amazing, underutilized, highly nutritious crops that can grow in all of these climate conditions.
And how do legumes compare with the current staple foods on the market?
In terms of price,
Nutritional value and sustainability, of course.
nutrition wise, there is no comparison. Legumes by far will outweigh any of the staple crops, by far. Always, every time, every day. Staple crops, they try and fortify, or at least the when, say, for example, you have wheat and you've made your flour. What happens after that is the fortification. You add your minerals and maybe some vitamins, and that's how people currently are seeing the agriculture accommodating for it. That we've been doing for quite some time.
I assume adding the nutrition afterwards is what makes it more expensive to sustain, correct? Where with legumes, it's already, the nutritional value is already within the plant.
Yes. Yes. So you don't need to modify anything.
How do they compare with regards to needs, like water needs and soil? Can they grow in any soil? Can they grow in the same soil that, for instance, wheat gets grown in?
So here's the magical thing about legumes. They're way better than any of the staple crops. So because they make these nodules, because they actually have this symbiotic relationship with the bacteria, they are very smart at their own fertilization processes, to the point where if you, and this is something called intercropping, if you actually have a wheat field and next year you plant legumes there, your soil for the next year is going to be much healthier than it was before the legumes.
Wow.
Okay, so the legumes can already grow in fertilized conditions. So I'd say it's a benefit. That is where we need to break the cycle for people to actually understand. There's more of a benefit than just to the body. The environment can also benefit.
So does that mean legumes produce their own fertilizer?
You could technically say so, yes.
So would your recommendation be then for farmers to plant every alternative year, plant legumes?
Somebody who farms will absolutely scrutinize this, but even if you have one row legume, one row wheat, and I'm not thinking mega, there's a sustainable way of farming. That is called intercropping as well. If you intersperse your crops like that, you keep your soil healthy. But the ideal is to, and I think people are doing this, the canola fields so gorgeous, always with the yellow flowers. If you see all of that, that is the exact same principle as planting legumes. So the canola would enrich the soil, and the next year, or you plant your wheat or your barley. Legumes can do that and bring nutritious food.
But would that also then mean that farmers would need to add less fertilizer to the ground?
Yes, that is absolutely the essence of these legume plants. If they fertilize, if they enrich the soil to such a level that you don't need to then go and fertilize necessarily to that extent of agriculture.
And bacteria-wise, I mean, obviously all plants and crop species have their own organisms that they're prone to, like fungus or whatever. So how does that affect, for example, farmers' wheat farm if they have legumes growing the same field?
Well, definitely that is something I'm going to need to look at. Pathogens not going to stay behind, and the world is not perfect. In agriculture, you're going to find fungus, you're going to find insects. It's going to pester your crops. But we come to sustainable agriculture, you're always going to find something of a biological method that you can use. The essence is scientists love to predict all the problems too, and that stops us from trying. When you're in it and you're immersed in it, you're going to see the problem and you're going to find a solution to the problem. Otherwise, we don't. I always laugh because it's so easy to theorize around all the problems. You never actually have a solution.
a lot of problems could be solved with genetically modified crops, but obviously there's a stigma or mental blockage to people around GMOs. So what's your viewpoint on GMOs?
Hey, listen, I'm a biotechnologist. I'm for GMOs.
But I mean, like in terms of commercial use, like what would you say to people, asking about genetic modified organisms and the safety around it?
Oh, no, listen, there's a lot of caution, a lot of safety aspects, and that I know people are afraid to enter into a realm of, for example, antibiotics and the use of these things for our crops. And I will consider genetic modification from the perspective where it's a tool for us to enhance something out there. If you can now, for example, grow a crop, let's grow legumes and say our staple crops no longer exist. And we genetically modify a legume to absorb more during the photosynthesis process so that, it produces more of a specific metabolite. And at the end of the day, it's nutritious and nutritious. So you're forcing it to make something more for you. That is one aspect that still requires a hell of a lot of land, which I think is where we currently sit. But I don't believe we're going to sit for too long as scientists. So the world is not necessarily going to rely on land like we imagine it today. So genetic modification in that essence is that they're not also taking a gene out, making recombinant products with it in the laboratory and selling that to someone to eat. For me, those are all down the line of genetic modification, production. It's exploiting a tool. And that is my go around genetic modification. People are bad mouthing a lot of it. I entered biotechnology with that knowledge, knowing people don't like. There's always a debate about a GM anything. From a biotechnologist viewpoint, this is an exceptionally good tool for us to help ourselves going forward. And it's not just about the genetic modification plant in the field. There's many more things I believe people should consider when we talk genetic modification. Even if we talk insulin production, which is made in a laboratory these days, many people take it. That is genetic modification of a bacteria. So my question to people always, if you are on the suffering end, are you going to say no to a GM?
People are fine with the use of pesticides and antibiotics and so forth in their crops, but you could technically genetically modify a crop to not need a pesticide or something because it can produce its own antibodies or produce its own pesticides naturally. Are you going to eat the genetic modified crop, or are you going to allow them to spray it with pesticides that could potentially cause cancer? Why do you think people have this thing against the word GMO? Why is this such a concerning topic?
People don't like to hear that something's been deeply modified to its core. I think it's the word genetic modification, because you're going to the core and you are changing something that was seemingly natural and is now still natural but enhanced. Hence my bringing in many non-GMO strategies as a biotechnologist to the table.
It's still all a form of genetically modifying by exposing it to external influences. You're still modifying the genetics of the plant without actually, going inside the cell or altering the nucleus. It's still the expression of genes and change in expression of genes when you do that. So it still falls under the same umbrella,
Right.
really.
I always start a debate like that because I do get it in the classroom often. What's your take on GMOs? And then I just have to always say, when we do breeding, that takes years and years and years for a new trait to come onto the market, something that's better equipped now to grow in these pest conditions or so on and so forth. Is that not genetic modification? Because it is. Over time, you are altering the genes of that plant. You breed it.
It's just taking longer.
Together. Yeah.
Yeah. Where if you just altered it, you could have created something 10 years ago that was more sustainable and could increase or decrease food shortages.
Yes, absolutely. And South Africa, I must also applaud because we've got some of the most progressive GMO laws in this country, and we're not using it as scientists because we can actually get our genetic modified crops out there.
Why do you think that is?
Because we publish and we stop. So that's what I'm saying. I often scrutinize in a scientific world like this. We publish and we don't do anything. I would scrutinize. If I publish microgreens and I don't do anything with it, I don't try and do something with it, that for me is not the essence of science. And I really believe that's a problem. We box the scientific mind in a university setting, and very few entrepreneurs are there showing people that they're thinking like scientists, they're doing stuff, So we box it in a university and we find the most amazing things and we put it in a thesis and we put it in the library. Never to be read again, never to be used again. And someone very important government once said, for all our 27 universities, we already have the answers to all of our problems in South Africa. We must just go and look.
I believe also it's our responsibility as scientists to do something with the research because, like you said, a lot of research goes and sits in a library and we believe somewhere someone's going to read it and they're going to do something with it. But more often than not, nothing ever gets done with that research. It's just sitting there.
Definitely. Let me also just, in a very balanced viewpoint, I do appreciate we need scientists. We need people to describe. We need people to show us, listen, that's there. That's the description of the genetic modification. There's your trials. That's what you did. There's also this gap, and I'm still learning a lot. Listen, I have not even matched 1% of what I believe I can learn as an entrepreneur out here. But if you know that this is what's happening in a university setting, how do you as an entrepreneur come in? And then how do we take out without infringing on IP, taking away from someone's work? Because that's the other thing. It's always this cycle. It's always this loop. You did amazing work. Now you can't do it because it's IP. And you want to take it out into the world and you actually want to show people I can commercialize something. There's a triangle there that I believe we need to try and walk through. So as an entrepreneur, come in, where's all of our solutions in higher education, publicly available? How are we going to commercialize it without trying to step on anyone? And that's why I say I'm calling on partners, because if we work together, if we start working together, I bet you it's going to be easier to solve some problems.
How does IP work in an industry like that? I mean, it's genes, right? It is something that can come across naturally. So say you alter a crop to have a specific gene, but somewhere in the world that crop already has a gene. How do you have IP on something that's actually natural?
You can't protect a gene as per se, but you protect the technology. So say a gene was placed in a crop for making more sucrose, right? That is the technology. So it is the process of that gene in that crop for that purpose. And those three aspects, that's called the technology that you can patent. But for sure, you can't patent a gene, you cannot patent a crop, and you cannot patent the product that it makes.
Okay, but that being said, now if you do have a crop and you create it to create more sugar, what would stop someone else from just, taking a seed from that plot and then growing and making their own crops from something that you created? Is that maybe where the blockage comes from in terms of GMO? You spend so much money on creating a GMO, and then someone else comes along and uses your same crops and grows from there.
So there's many, many, many example in the world of patents where this has happened. Because the moment you put a patent out there, you're pretty much describing everything, the whole process, everything you're using. And it is quite easy for people to either change something super small and say they're not infringing on your patent, and they are actually right, unless you had all of that structure in your patent, which you can't predict always. So I see that world very differently too. I think patenting very frequently boxes you. It boxes what you can do with a discovery. So if I have to actually give anyone advice, if you have products or something that you're designing, there's something called a know-how. So that is your technique of doing something, and that know-how is a real legit thing in law. That is your method, that is your process. And I think that often goes better in spending many years trying to patent something. If you have the most amazing next best thing out there, go for it, patent. I'm not saying don't patent. I am not in big on the patenting because of the box.
How do you know when you've got something like an idea that's commercially viable versus something that isn't? And how do you make that recognition?
You're gonna have to go do research. You have to start searching properly. Firstly, your concept, and in global. For example, if it was this, the spheres with the nutrition.
How do you get people to change their mindset on something like water with sago M, water with spears? It's not, it's a funny texture. I mean, you get those with the chia seeds, and a lot of people aren't so fond of it because of the texture though it has. So how do you get people to get around that and change their mindsets to be more open to things that are unfamiliar?
Well, I think that will all start with some form of consumer testing, because even when it comes to the target market or the people out there, the consumers that need to drink or eat your product now, there will be a portion that will not like it, and there will be a portion that will scrutinize it, and there will be a portion that will love it and want to try it and be adventurous. So if you, like, for example, if we do sensory on some of the products that we design, we get a consumer tasting going, and we get live feedback. We get feedback from people. Would you even buy this? How much would you pay for it? Do you like it? What would you want to change? And that is where we do the translation. We don't science that, even though it's a scientific method. There's information that you get from consumers that partake in your product development. That is where we need to break from science. As someone who develops products, you need to be in there with your consumers. You need to understand the pain before it is a pain on the shelf. So that is how we kind of involve, very small scale, but we get feedback, and from that feedback, we can either adapt this way or that way to make the product.
When you look back on your life, what would be the thing that stands out to you? What would be the goal for you?
The goal for me is almost like, did I use my science as a skill and not just as an acquisition of knowledge that sits in my head? So it's an ultimate milestone of life. But if I have to look back, and if it's something that I needed to rub off on everyone, which is myself too, find the fun in everything that you do. Fun is super important. Science it's not a serious topic. It's very fun. Yes, it can become quite serious if you get frustrated in a laboratory scenario and so on. But if there's anything I would like to leave behind is always find the fun in what you do in your science, And you are going to see how much you're going to learn for that and how quickly you're going to start developing, frugal innovations.
What stands out for you when you look at your life at the moment? What stands out for you? Any career highlights? Any memorable moments?
I will never now let any one person stand out, but rather participated so far, and it's not the end of those. 2 articles, yes, articles in Frontiers in Young Minds. So, when I say, hey, I scrutinize all these scientists without publishing their science, I really enjoy communicating my science to young children, and it gets reviewed by children. And essentially, if you can communicate your science to young minds the right way and establish science as just another skill and another tool that you can do amazing things with, that for me is always going to be a highlight of my career. Where do you start inspiring?
Yeah, is it just the two that you published? Those 2 articles in Frontiers Science?
I've published more in science, yes, but that is a huge look back on a scientific career if you are able to translate your science mind for the child to enjoy.
Do you have any message for young scientists?
I think many people who cross our doors know that we also almost live by a credo with our training. But if you go into life, plan, prepare, execute, and keep those 3 things in mind, because execution shouldn't happen without proper planning and preparation. And if you do that, do consider that scientists can do many more things with that mind. You've been training as a scientist. It doesn't matter how many degrees you have. And you don't need to go all the way with degrees too. You don't need to go all the way to a PhD, MSc to use your mind, the science mind, right? And that for me is the biggest thing is don't be blinded by people who tell you there are no jobs. First, go and find the fun in your science. And you're going to start seeing how many things you can do with the mind that you have trained for those couple of years that you've been putting knowledge into.
Thank you so much, Bianke, for joining us today. Yes. It was so interesting to speak to you. And for the listeners, where can they find you if they're looking for you?
Definitely. Okay. Apart from LinkedIn, Bianke Loedolff. But you can also find my company, BioSupport. You can also find me on LinkedIn there, or you can go and visit my website, www.biosupport.co.za. And happy to engage.
Fantastic. Thank you very much. Thanks for joining us for today's episode of Under the Microphone. If you enjoyed this episode, please like and subscribe. It really helps a lot. We would also like to give a big thank you to our sponsors. To find out more about them, please click on the link below. If you would like to get involved as a guest or a sponsor, please contact us at under.the.mic@relab.co.za. And tune in again next week for our next episode on Wednesday at Under the Microphone.